Picture this. You're standing on the surface of Venus, looking up at the night sky. You're expecting to see a moon, maybe two, hanging there like Earth's faithful companion. But there's nothing, just stars. Now teleport to Mercury, the closest planet to the Sun. Same story. No moon, not even a tiny one. Before we get started, check out the link in the description to download our ebook. So here's the question that's been bugging astronomers for centuries. Why are Mercury and Venus the only two planets in our solar system without a single moon? Mars has 2. Jupiter has 95. Even distant Neptune has 16. But Mercury and Venus, 0. Zilch. Nada. Today, we're diving into one of the solar system's most fascinating mysteries. And trust me, the answer is way more interesting than you might think. Welcome back to the channel. If you're new here, hit that subscribe button because we explore the weird, the wonderful, and the downright mysterious corners of our universe. Now, before we solve this cosmic puzzle, let's establish something important. Having moons isn't exactly rare in our solar system. Out of the 8 planets, 6 of them have moons. That's 75%. Earth has 1. Mars has 2 small ones. And the gas giants, they're practically moon collectors. Jupiter alone has almost 100 moons orbiting it. So what's going on with Mercury and Venus? Are they just unlucky? Did they lose their moons in some cosmic catastrophe? Or is there something about these 2 planets that makes having a moon basically impossible? Let's find out. Before we can understand why Mercury and Venus don't have moons, we need to understand what it takes for a planet to keep a moon in the first place. Think of a moon like a dog on a leash. The planet is the owner, and gravity is the leash. For that leash to work, it needs to be strong enough to hold the dog, but not so tight that it pulls the dog into the owner. Make sense? For a moon to orbit a planet successfully, it needs to be within what scientists call the Hill sphere. This is basically the zone around a planet where its gravity is the boss. Inside the Hill sphere, the planet's gravity dominates. Outside of it, other forces, like the sun's gravity, take over. Here's where it gets interesting. The size of a planet's Hill sphere depends on 3 things: how massive the planet is, how far it is from the sun, and how massive the sun is. Bigger planets have bigger Hill spheres. Planets farther from the sun also have bigger Hill spheres because the sun's gravitational influence weakens with distance. It's like trying to control a dog on a leash while standing really far away. The farther you are from distractions, the easier it is. Now let's talk about Mercury and Venus. Spoiler alert, they're in a tough neighborhood. Let's start with Mercury, the smallest planet in our solar system and the closest to the sun. Mercury is tiny. It's only slightly larger than Earth's moon. Because it's so small, it doesn't have a lot of gravitational pull. That means its Hill sphere, that zone where it can hold onto a moon, is incredibly small. But size isn't Mercury's only problem. It's also ridiculously close to the sun. We're talking 36 million miles on average. That might sound like a lot, but in space terms, that's basically next door. Here's the issue. When you're that close to the sun's gravity is absolutely overwhelming. It's like trying to have a conversation at a rock concert. The sun's gravitational pull is so strong that it dominates everything in Mercury's neighborhood. Even if Mercury somehow captured a moon, that moon would need to orbit extremely close to Mercury to stay within its tiny Hill sphere. And here's the kicker. If a moon orbits too close to a planet, tidal forces can rip it apart. It's a lose-lose situation. Scientists estimate that for a moon to survive around Mercury, it would need to orbit within about 120 miles of the surface. That's closer than the International Space Station orbits Earth. At that distance, the moon would be torn apart by tidal forces before you could even name it. But wait, there's more. Mercury's orbit around the sun is extremely elliptical. That means its distance from the sun changes dramatically. When Mercury swings closer to the sun, any potential moon would get yanked around by the sun's gravity. It would be like trying to keep a balloon on a string during a hurricane. So, Mercury's situation is pretty clear. It's too small, too close to the sun, and in too chaotic an orbit to hold on to a moon. Mystery solved for Mercury, right? Well, mostly. But Venus is where things get really interesting. Venus is often called Earth's twin. It's almost the same size as Earth. It has a similar mass and density. If any planet should have a moon, it's Venus. But it doesn't. Why? Venus is farther from the sun than Mercury, about 67 million miles away. That gives it a more reasonable Hill sphere. It's also much more massive than Mercury, which means stronger gravity. On paper, Venus should absolutely be able to hold onto a moon. So what happened? Here's where we enter the realm of scientific theories and mysteries, because the truth is, we don't know for sure, but scientists have some fascinating ideas. The first theory is the simplest. Maybe Venus never had a moon to begin with. When planets form, there are generally 3 ways they can get moons. First, a moon can form alongside the planet from the same disk of material. That's probably how Earth's moon formed, though in Earth's case, it involved a massive collision. Second, a planet can capture a passing asteroid or comet with its gravity. That's likely what happened with Mars to tiny moons. Third, a collision can blast material into orbit that eventually clumps together into a moon. Maybe Venus just missed out on all 3 opportunities. Perhaps during the early chaotic days of the solar system, Venus simply didn't have the right conditions for moon formation. No big collision, no convenient asteroids passing by at just the right speed, just bad luck. But many astronomers find this unsatisfying. Venus had just as many opportunities as Earth did during the solar system's formation. So why would Venus end up empty-handed? This is where it gets dramatic. What if Venus did have a moon, but something happened to it? One popular theory involves Venus rotation. Here's something weird about Venus. It rotates backwards compared to most other planets, and it rotates incredibly slowly. One day on Venus lasts 243 Earth days. That's longer than a Venusian year, which is only 225 Earth days. Something catastrophic must have happened to cause this backward, super slow rotation. The leading theory, a massive collision early in Venus history. Imagine a planet-sized object slamming into Venus billions of years ago. The impact would have been violent enough to flip Venus rotation. And if Venus had a moon at the time, that collision could have sent the moon spiraling either out into space or crashing back into Venus. There's another possibility involving tidal forces. See, moons and planets play a constant game of gravitational tug-of-war. Earth's moon, for example, is slowly drifting away from us at about 1.5 inches per year. But tidal forces can also work in reverse, pulling a moon closer to its planet. Some scientists think Venus might have had a moon that gradually spiraled inward due to tidal forces, eventually getting so close that it broke apart and crashed into Venus. This process would take millions of years, but we've got billions of years of solar system history to work with. The evidence for this, well, that's the problem. There isn't much. Venus' surface is relatively young, geologically speaking. Massive volcanic activity has essentially resurfaced the entire planet within the last billion years or so, erasing any evidence of ancient moons or impacts. It's like trying to solve a murder mystery where someone's cleaned the entire crime scene. Frustrating, right? Here's a wild one that'll blow your mind. Some scientists have proposed that Venus might have had not 1, but 2 moons at some point. Computer simulations have shown that if Venus had 2 moons orbiting in opposite directions, they could have eventually collided with each other. The resulting debris would either rain down on Venus or scatter into space. This theory is speculative, but it's based on solid physics. We know that multi-moon systems can be unstable, especially when the moons are orbiting in different directions or at different speeds. Over millions of years, their orbits can shift, and eventually, they collide. Think of it like 2 cars driving on the same circular track at different speeds. Eventually, the faster car is going to catch up to the slower one, crash. But again, without evidence, this remains in the realm of fascinating speculation. There's another player in this mystery that we haven't talked about yet, the solar wind. The solar wind is a constant stream of charged particles flowing from the sun. Near the sun, this wind is incredibly strong. It can literally blow gases and even small particles away from planets. Mercury and Venus are both close enough to the sun that the solar wind is a major factor. Some scientists think that even if these planets tried to form moons from debris disks early in their history, the solar wind could have blown that material away before it had a chance to clump together. It's like trying to build a sandcastle during a windstorm. The materials are there, but the conditions won't let it happen. The solar wind might also explain why any captured moons wouldn't last long. Small moons, especially ones made of ice or loose rock, could gradually get eroded by the solar wind and lose material until there's nothing left. Let's put Mercury and Venus situation in perspective by looking at the rest of the solar system. Earth has 1 large moon, likely formed from a massive collision early in its history. Mars has two tiny moons, Phobos and Deimos, which are probably captured asteroids. Both Earth and Mars are farther from the Sun than Venus, giving them larger hill spheres and less interference from solar gravity and solar wind. Now look at the gas giants. Jupiter, Saturn, Uranus, and Neptune are all incredibly far from the Sun. They're also massive, with enormous hill spheres. They can hold on to moons easily. Jupiter's largest moon, Ganymede, is bigger than the planet Mercury. These giant planets had plenty of material to work with during formation, and their strong gravity meant they could capture passing objects. Mercury and Venus, by contrast, are playing on hard mode. They're small, they're close to the Sun, and they formed in a region of the solar system where material was scarcer, and competition from the Sun's gravity was fierce. So, have we solved the mystery? Well, partially. For Mercury, the answer is pretty clear. It's too small and too close to the Sun to hold on to a moon. Even if it captured one temporarily, the moon wouldn't survive long. Case closed. Venus is the real enigma. It should be able to support a moon, but it doesn't have one. Did it never form one? Did it lose one to a catastrophic collision? Did two moons destroy each other? We simply don't know. What makes this so frustrating and fascinating is that Venus is right there, relatively close to Earth. We've sent dozens of missions to study it, but Venus is incredibly hostile. Its surface temperature is hot enough to melt lead, its atmospheric pressure is crushing, and its clouds are made of sulfuric acid. Studying Venus history is incredibly difficult. Future missions might give us more clues. NASA and other space agencies are planning new Venus missions that could help us understand its geological history better. Maybe we'll find evidence of ancient moon impacts or other clues hidden beneath those thick clouds. Here's what I love about this mystery. It reminds us how dynamic and violent the early solar system was. We look at the planets today and they seem so stable, so permanent, but billions of years ago, it was chaos. Planets were still forming, massive collisions were common, and the whole system was sorting itself out through cosmic violence. Mercury and Venus are survivors of that chaos. They're shaped by their environment, by their proximity to the Sun. By ancient collisions, we can only guess at the fact that they don't have moons isn't a failure. It's a story written in gravity and physics. And here's something else to think about. Earth is incredibly lucky. Our moon stabilizes our rotation, creates tides that may have been crucial for the development of life, and lights up our night sky. If Earth had formed a bit closer to the Sun, or had a slightly different history, we might be moonless too. So there you have it, the mystery of Mercury and Venus missing moons. Mercury's case is straightforward. It's too small, too close to the Sun, and in too unstable an orbit. Physics simply doesn't allow it to keep a moon. Venus is the real puzzle. It has the size and mass to support a moon, but something prevented it from having one or took it away. Whether Venus never had a moon, lost one to a collision, or saw two moons destroy each other remains one of the solar system's unanswered questions. And that's okay. Not every mystery has a tidy solution. Sometimes the questions are just as fascinating as the answers. What do you think happened? Do you buy the collision theory, or do you think Venus never had a moon to begin with? Drop your thoughts in the comments below. If you enjoyed this deep dive into planetary science, smash that like button and subscribe for more space mysteries. We've got plenty more cosmic puzzles to explore. And remember, every time you look up at our moon, appreciate it a little more. We're lucky to have it. Not every planet can say the same. Thanks for watching, and keep looking up. The universe is full of mysteries waiting to be solved. See you in the next video.